So let's talk about where these axial and equatorial atoms come from in cyclohexane. To do this, we're going to use a Newman projection, and we're going to use it on basically the chair conformation. If we were looking at the chairs side on, where we see the top carbon and the bottom carbon, we took the top carbon, bottom carbon, and looked at it like this. So let's take our C6 ring and our chair conformation. And what we're going to do, sorry for how poorly this is drawn, what we're going to do is we're going to look along this carbon-carbon bond and this carbon-carbon bond. So we've got our Newman projections. This carbon here is the front carbon. This carbon here is the back carbon. Back carbon. And your front carbon. So if you're looking down these bonds, what we see is that we've got one conformation. Well, we've got the carbons up front, and then we've got the carbons in the back. And the rest of our projection is an H, and H, and H, and H. And on the back side, sorry, we're going to need to erase these here. H, 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 and H. So as we look along these two carbons, what we see is that we have hydrogens that point up and down that are staggered from each other. And then we have these hydrogens on the side, one up, one down. Now, these, because of this 6 degree, this gauche angle, these are actually fairly stable relative to each other. These actually begin to see problems. These axial atoms begin to see problems because they are standing up. And if they occupy any space, if there's something bigger than a hydrogen, they're going to basically interfere with each other. So these up-down hydrogens here are your axial hydrogens, or axial positions. These you see that looking along the carbon bond are gauche to each other. These are your equatorial hydrogens. And if we were to look at these carbons, we would see a similar thing. So let's say, I don't really know how you would draw that with a Newman projection. But we're going to see the same thing with these hydrogens as well. There are some that point out along the plane of the ring, and then there's going to be a hydrogen that points up or down relative to its position. So in this case, we're going to have our carbon. We are going to have a hydrogen that kind of sticks out of the board, but then we're going to have a hydrogen that goes up. This one. We're going to have a hydrogen that goes down, and hydrogen that points into the plane on the board. So this is what gives rise to our axial and equatorial. Now, again, we can just take this ring and we can keep rotating it to the board, and we're going to see this. But effectively, what makes the equatorial atoms more stable is the fact that they are gauche to each other. Whereas your axials point up and above and below the ring, they're actually going to see some type of crowding.